My name is Charles Butiko from the Eldoret National Polytechnic and affiliated for the purpose of this innovation, affiliated with IDC Center in Vihiga County. And it is as titled, Bagasse Activated Carbon, Purified Sweet Sorghum, Sugarcane Fortified Liquid Sugar. It is a case study where we proposed a PPP between research institutions and the private sector. Okay. Today, we would like to answer this question. Must sugar be crystallized? And must sugar come from sugarcane? This is part of what our innovation was trying to answer. And according to the Sugar Act of 2024, sugar can be crystalline or liquid in any of their recognized commercial forms. And fortunately or unfortunately, we have not been able to exploit the other part where we can come up with the liquid form of sugar. And on sugar raw material, in Kenya right now, we have had we have only known one raw material, which is sugarcane, but there has been diversification of raw materials like the sugar beets. And for our case, we are focusing on the sweet sorghum. And we are focusing on sweet sorghum because of its climate resilience, because of the ability to regenerate within a short time, and most important, because of the ability to come up with a fortified product. And because of health benefits, so many consumers are focusing on product fortification. Our research objectives was, first of all, to come up with an optimized formulation of the ratio of sweet sorghum sugar, liquid sugar, to that of sugarcane. And the second objective was to innovate around and come up with a cost-effective way of purifying the same sugar. The third objective was to do a cost-benefit analysis, which you will see we have already done. And last but not least was our focus on it as a case study, where we can be able to rope in more youths into early career entry into the sugar industry. And our methodology was simplified, where we used simple equipment like the juice extractor, the collection drums. We also used drums for heating and collection. And we used an instrument called a bricks refractometer for solids measurement. And for the activated carbon, we used a drum for pyrolysis, and we used some material for activation, that is the lemon juice for activation, which is an acceptable lab scale method. And on the methodology, we started right from the farm. We worked with a seed bank based in Vihiga County, where we obtained the sweet sorghum seeds of two varieties, namely Liquenjali and KT1. And we networked with the sugarcane farmers who enabled us to get the D8484 and the Ken 82216. Those are stocks. For sugarcane, we went direct to the stocks, but we had to wait for our sweet sorghum. And then for the raw materials, we took samples of 100 kilograms per batch, and we were able to extract the juice separately. And that juice we were able to heat it up under certain conditions, and when we concentrated it, we were guided by some technical information up to a certain level in a drum to be able to concentrate it up to a level of 10 liters. Then separately for the sweet sorghum solution, for the two types, we were able to combine, and for the sugarcane solutions, we were able to combine. Then in the last procedure, we were able to separate the two. We were able to separate the two and pass them through two filters, which were based on activated carbon and a normal sand filter that is separately. Then the final product that we got from the activated carbon filter and the sand filter, we were able to also get a final combination for the sweet sorghum, and to be able to get the final combination of the sugarcane mixture. And thereafter, we were able to do certain measurements to our capacity. We mostly used the bricks measurements, and part of the limitation was that there were some aspects of quality like the pole, which we could not be able to measure, but based on some physical tests, it covered for the limitation. The research methodology was based on what we call criterion validity. Criterion validity is a method where you have a certain value that you are targeting. It could be it could conform to it or not, and we were using that because we were doing a combination. So we were able to come up with what we found out to be the best formulation that conformed to an acceptable standard. And for our results, during the juice extraction, we found out that by running a using an extractor of a 50 liter per hour for each of the varieties of the 100 kilograms, we found out that the juice from the first variety of sweet sorghum was more, as you can see, was slightly more than from the KT1. And at the same time, the one from 84 was slightly more than the one from 82 to 16. And the bricks values, for the bricks values, the one for KT1 was slightly higher than the one for liquid jelly, while the one for the sugarcane, the one for 82 to 16 was slightly higher than the one for D84. And after the heating, the way I had described, we found out that the bricks values for the SS1, that's sweet sorghum, that's the liquid jelly, was slightly less than, that's the bricks values was slightly less than the KT1, while the one for, in the sugarcane, the one for 82 to 16 was slightly more than the one for D84. And the time taken for heating, to achieve the 10 liter mark, we found out that where the bricks values were higher, it took a lesser time than where the bricks values were less. Then finally, after the filtration, the bricks values increased accordingly, where in the mixed sweet sorghum, in the mixed sweet sorghum, the one that passed through the activated carbon filter was a figure of 68.5, while the one that passed through the sand filter gave a figure of 67.5, while on the other hand, for the sugarcane, the one that passed through the activated carbon filter was 67, and the one that passed through the sand filter was 65. On bricks-based optimization, the bricks values in the SE column were found to be slightly higher than the one for the sand filter column, and we carried out a mathematical optimization where, because I had told you that we were combining half-half, and so based on the bricks values, 0.5 of 67.5 plus 0.5 of 68.5 gave us 68, while 0.5 of 65 and 0.5 of 67 gave us 67. And for criterion validity, we had to do the blends as per 1-to-1 ratio, 1-to-2, and 2-to-1. That is for sweet sorghum and sugarcane, respectively. And based on that, we were able to get the optimal ratio of 2-to-1, sweet sorghum to sugarcane at 67.3. And then the cost-benefit analysis, was done, but only after the optimized blend liquid sugar was tested for equivalence with the crystalline sugar. And then on the cost-benefit analysis, we found out, based on market values of the cost of sugar and the research market value on the cost of sweet sorghum, we found out that one could make a saving on the cost of Kenya shillings 60.75, that is per liter. That's per liter of the blended mixture. And then we did some calculations, as you can see there, to ascertain that. And we finally concluded that it is possible to come up with the optimal combination of the sweet sorghum and sugarcane. We also found out that activated carbon can give better results and can be more cost effective.
A big round of applause for Bwana Charles. Thank you so much. We appreciate you.